check out this excellent calculator active question. How do we know it's calculator active? Because I said so. It'd be impossible to do without a calculator unless you are one of the probably 7 or 8 people in the world that can do this in your head. State every interval on which this function is concave down. We are looking for where the second derivative is negative. I think that's worth writing. So second derivative is negative for this interval from 0 to 5. So we're going to write an interval or two that demonstrates where this is concave down. So first thing we need to do is find the second derivative, right? So since it is calculator active, based on the craziness and based on the fact that I'm telling you, then let's not find the derivative. I'm going to show you a cool trick. You're going to love it, love it, love it, love it. Here we go. Y equals, type the function, 1/4 x squared minus e to the, all right, by the way, e has a couple options. You can get it here. I'm going to use this one on the ln button because it has an exponent built in. Second and ln. E to the cosine x, make sure you are in radians. You probably are. Okay, this is the function. I'm going to graph it from 0 to 5. You don't have to do this. It's a waste of time, but I'm just demonstrating. 0 to 5, zoom 0. Zoom 0. Sorry. Zoom 0 is zoom fit, and that will adjust it accordingly. I want to know where this graph is concave down. Yeah, good luck with that. It looks almost straight right here, and I can't tell. I mean, if it's curved, it's very slight. This looks like it's concave up. But around here, it looks a little concave down, and here I can't tell. It's just so subtle. Good luck with that. Let's find the second derivative. Y equals. Now, we could find the second derivative by hand pretty easily. It involves just basic stuff like power rule. Also, chain rule, and then we'd have product involved in taking the next derivative, product with chain. It gets a little complicated, doable, but complicated. So let's not. The derivative of this is, well, press math, and I want the derivative. Whoops, whoa, no, that's not it. Escape. Okay, there we go. Derivative. I want the derivative with respect to x of y1, and I can get to y1 very easily by pressing, you may not have seen this before, you may have, alpha and trace, and that helps me retrieve y1. And I think you have seen this before, I want the derivative at any given x value, so x equals x. So as it graphs it like x by x, it's going to be doing that, finding the derivative. Okay, let's find the derivative of that. The derivative of that is, well, the derivative of y2. So math, in derivative, you could just press 8. The derivative with respect to x of y2. Alpha trace, go to y2 and at any given x value. Okay, I'll let you stare at that, type that if you're following along. If you graphed this, first of all, it may not show up everything you need. Second of all, it's going to show all 3 graphs. It's going to show your original function, your derivative, your second derivative. I don't want all that. That is too much. I want the second derivative. That's all I want. I want to know where the second derivative is negative, below the x-axis. So let's just turn off everything but the second derivative. I'm going to come up. I'm going to go over to the equal marks and press enter on the first derivative and on the original function. And now when it graphs, it'll only graph the second derivative. And it's going to take it a minute because it's taking a derivative and then taking a derivative point by point by point by point by point. It's a slow process. I might have time to tell a story while it's graphing. And while it's graphing, actually, in order to graph it, I should say, we're going to press zoom, and we're going to do zoom fit again. This is a great option. This basically just graphs the y values based on the x values that are provided. Now, I'm going to press window. If you're following along and you don't have 0, 5 as your x and your x minimum and maximum, do that. Because it's going to take 0 to 5 and then find the highest, find the lowest, and adjust it accordingly. And it's going to take it a minute. So I might have to pull out finger puppets or whatever. So zoom 0 is zoom fit, and there it goes. And it's taking a while. So while it's graphing, oh my goodness, his absolute value arms didn't quite meet at his body, but he's happy. And there he is. He's happy to be here. And here it goes. See how slow it's going? But enough about that. Let's talk about Mr. Happy Hat. And he is excited. Let's graph. And then there's a calculator over here, and he's like, let's do it slowly. Here we go, and then there's all your buttons, and do-do-do-do, do-do-do-do-do-do-do-do-do-do-do, do-do-do-do-do. And it's graphing it. I'm gonna graph it in blue, and it goes down. You don't have to draw this. There it is. There we go. All right. Had time to draw. Look at this. I want to know every interval where the function is concave downless, where the second derivative is negative. Let me slide this down a little bit. And it's going to be for the interval from 0 to 5. That is here and here. Let's find out where there and there are. I need to know this x value, this x value, this x value, and that x value is 5, so it ends at 5. So final answer is going to be an interval and another interval from somewhere to 5. Second, calc 0, left bound. Okay, so I'm going to aim for this one first, and I'm going to go just a little bit to the left of it, and it's going to be a slow process. Might even have time to draw a little cartoon. There we go. Go to the left, go to the right, press enter on guess. It'll take it a minute. And our first answer is going to be from 1.084, always 3 decimal places, to this x value. Let's find this one. Second, calc. 0. Goodness, sorry. Been a long day. All right, I'm aiming for this one, so I better be to the left of it. Actually, let's just go there. It might be a little bit too wide for its computational power at the moment, but it'll catch up. A little to the right of it, and somewhere in between is our answer. And it is 2.544, okay? And here is another interval where it is concave down, and it ends in 5. Now you might say, well, what about a bracket here? Because it does include, I know. The function is concave down. Actually, I think I will put a bracket there, and I don't think they would count off, they being people who grade the AP test. I don't think they'd count off for that, but technically the graph is neither concave up nor down at that x value, that x value, that x value, but it is below the x-axis at 5, so I'll put the bracket on that one. Okay, let's find this last one. We'll be done with this problem. I'm going to be to the left of that x value. There we go. And you could just type numbers. For example, I could type a 4. There it is. See, I knew 4 was greater than that. There we go. It's going to be 3 point something. 3 point, oh, guess. I did. 3.739. There we go. That's where the graph is concave down, my friends.